Well, thanks for coming, and thanks for the SmartBear team for inviting me to come. Like Nathan said, I'm Travis Koenig. I work for RealPage. If anyone's not familiar with RealPage, which probably most of you aren't, it's a software company that does real estate, property management, anything in that kind of zone. I've been probably working with SmartBear team for about 1.5 years now, I think. Familiar with Swagger products way back before that, but in more modern times working with them on Swaggerhub and different things around that. So when they asked me to come speak at this conference, I was trying to think of what's a good topic to talk about. And so what I was going to go through is just kind of a little bit about the journey that we're taking at RealPage with my teams and how we're kind of approaching modernizing a little bit of API development, coming from more monolithic structures, kind of old legacy models, things like that. How do we move forward and get to production quicker, things like that. So that's just a quick introduction I already did. And these are kind of some of the challenges that we face. And any of you that work in enterprise environments are probably familiar with this kind of stuff. Probably the first one I should have put there that's not there is speed to production. Our release cycles are way too long. Some of them are a quarter before we release a product. So that's something we really wanted to address. Other major things, lack of communication. We acquire a lot of companies. If any of you work for companies like that are acquiring all the time, you're probably familiar with that. Sometimes it feels like you're a lot of different companies under one hood instead of a single unified version. Arbitrary deadlines is probably just a reality of the business, especially in publicly traded companies. They're always promising stuff. You got to deliver. That's just the way it goes. And different tech skills and stacks, especially when you're acquiring a lot of companies like we do. You have big teams, a lot of teams around the world. They're using different tools, different stacks, different structures. It doesn't always integrate that well when you're trying to bring things together and unify. And then a lack of documentation. I'm sure everyone's familiar with that. We have many APIs that have no docs, partial docs, Word docs, Wiki docs, you name it, but they're not complete. Sometimes you can't even find who owns that API or it's docked at all. So I stole this picture from someone else who gave a presentation at the office because I felt like it's something we could relate to. Pretty much all our teams are working really hard, but they're not always working really smart. And it's sometimes hard to get people to stop and have a conversation about how we can do something better, how we can make it more efficient when everyone's just crunching, trying to get through these deadlines and trying to get this stuff out the door. So we had to find a better way, some way that we could start moving forward, migrate this to modern processes. And what we decided to do is kind of the basis of the rest of this presentation. So microservices, everyone's heard of that. It's a huge buzzword. It's starting to get into enterprise development these days. And it means a lot of different things to different people. I've talked to many people, seen people in my own company that read the word and think they understand what microservices is. So it's just a small service, that's it. I would suggest anyone getting into this space do themselves and their team a service and do your homework. Spend a little time researching what microservices are and what they're not, what the goal is, and how you can use them going forward. Just out of curiosity, in the room, how many people are either doing microservices or in the process of kind of trying to get to that kind of phase? Okay, so a decent amount. Has anyone done the journey all the way? Didn't think, okay. It's kind of an ongoing thing. A big thing is to understand the goal of what you're trying to do with microservices. The goal shouldn't be to do microservices. You need to have a reason to do it. You want to know what you're trying to get to. The big reasons for us to do it would be to get to production faster, right? We want to release code quicker. We want to test it quicker. And we want to integrate better. The other big thing is you need to understand the drawbacks. While there's a lot of benefits to what you can do with microservices, there's a lot of drawbacks too. Your complexity of your releases is going to go way up. You have a lot more environments. You have a lot more things to manage, a lot more moving parts. So you really need to take that into consideration when you're moving forward. If you're not moving forward in parallel with automated testing strategies, CI, CD, things like that, you're probably really going to struggle with microservices. And while I'm more in the development side, so there's not going to be a lot of talking here about the automated testing and things like that. The SmartBear team obviously has plenty of tools to work on that, and we have teams that focus on it. I'm just a little bit more focused on the dev side, selfishly. But that's a big part of moving forward in this strategy. You have to have that in place. So idealistic approach to microservices, if you do a lot of reading, blogs, books, you kind of come across what they should be, right? And these are some of kind of the high points. Single code responsibility, so they need to be small, focus on one thing. They own their own data, so theoretically they should sit on their own database. They're independently scalable, deployable, and testable, which is the big thing. You don't have to retest your entire monolithic structure to release one small code change. And in a lot of cases, they're fully decoupled. But that brings a whole other piece to the puzzle. You're using message queues now, and you have a lot more things to worry about. But if you want to be 100% decoupled, that's kind of the direction you need to go. Now, that's not always realistic. This is just kind of a high level of what that might look like. Now, that process is not always realistic. It wasn't realistic for us. We couldn't just break down a huge monolithic structure and go straight from A to Z, from where we were to where we wanted to go. It just wasn't going to work. There's too much work. There's too many things at play. So we were kind of looking at a more pragmatic approach to how can we get there steadily without refactoring over and over, but still make progress. And some of the things that you can do, we start out bigger, sorry. It's a lot easier to go smaller than it is to go too small, and then you have to reassemble it. If you don't understand your domain lines, you're not really sure where to split the services, it's a good reason to start a little bit bigger until you understand that, because you're going to create complexity that's not necessary. We've actually already seen in another team in my company, they did something very similar to this. They built tons and tons of services, and then they were struggling to deploy them. They weren't really separated correctly, and they are now piecing them all back together, doing a 180. And then they'll still be back in the same problem they had to start with. So you really want to do your homework and be careful with that, how you break it down. You can share a database. I know technically a microservice should own its own data, but sometimes big databases are hard to split up. It's a lot easier sometimes to separate the code. So that's something you can do. You can also share hosting. That becomes a challenge depending on where you host your services. If you're cloud-based, if you're fully on-prem, or if you're hybrid, it makes a big difference in how you do that. Out of curiosity, how many people here work for companies where everything is cloud? Only one. How many are all on-prem? A lot more. So, okay, that becomes a big deal. And of the people on-prem, do you have a full Kubernetes cluster, instance, containers, everything? Or are you still kind of migrating? Kind of on the way. So that becomes challenging when you start to deploy these things. It's really hard to deploy all microservices in their own VMs if you don't have that structure set up. It's a lot of work on IT. It's expensive. It's complicated to manage. So there's ways you can get there without having to go the whole way right up front. And the next few slides are kind of going through kind of some diagrams of how we're approaching that in a phased approach, where you can kind of get to the end goal without redoing everything, refactoring between each phase. And so one thing, you might start off where you're simply just splitting out some services from your monolith. You're sharing the same database, you're talking to other pieces, but you're still on the same host in the same DB. You're still getting some benefits here because your code's a little bit more separated. It's a smaller code base to manage. It's easier for new developers to onboard. You can still independently test and release. You're just not all the way there, but you're still gaining some ground. And then you can move into a little bit more advanced approach where you now split that out from shared hosting. So if you can deploy in containers, if you can deploy to the cloud in containers, you can kind of go to something like this. You're still sharing a database. You didn't do any refactor. You just split it out even further. Next phase, you might be fully decoupled. You have your own databases. You have your own services. Everything's deployed independently, whether it's containers or VMs, and you're talking to service. Now, this is going to start presenting a new challenge. If you start having a bunch of services that talk to each other, you're going to have configuration mess all over the place, firewall rules. Anytime you change where a service lives, a new container comes up, you're going to have to manage how you deploy that. And you start coming into another pattern that you might have heard of that you could use, which is an API Gateway pattern. Typically, you can use this in a couple ways. I think you most commonly see this in a north-south traffic pattern where you're taking traffic from outside your network inside and then dispersing it. If you have public APIs or whatever you might be doing, there's a lot of platforms that do this. Amazon has gateways, Mashery, Kong. We'll talk a little bit more about gateways as we go through this, but that's one pattern you can use to kind of put a little separation in here so you're not tightly coupled service to service. You have a little more orchestration ability. This is probably a little bit more what it actually looks like in the end. You'll have a combination of things connected point to point through potentially a gateway. and some decoupled stuff through messaging queues like Kafka or RabbitMQ. I don't think it's realistic, at least in our experience, to be fully decoupled where every single service you have is event-driven. You're still going to have times where you need to communicate service to service. And so a hybrid model is probably where you might end up. And in this model, you're looking at API gateway patterns that are centralized. So there is some upsides and downsides to that. Obviously, you know the downsides of being centralized. But it is a little bit easier to manage, and it's a good stepping stone if you're kind of moving into this pattern for the first time and developing these services. The next layer of that is splitting it out to a decentralized pattern, which would be more of a service mesh if you've been getting into this space. Those are deployed more as a sidecar pattern. You're not going through a central component anymore, but they're sitting alongside each microservice. It's a little bit more complex. Usually you see this in east-west traffic inside your network connecting microservice to microservice. And common platforms for this would be like Istio, Linkerd, things like that. We haven't actually, in our experience, got to this phase yet. It's kind of a little bit down the road. We're first still decoupling, piecing it together. Once we get a little bit more advanced, this is where we would like to go internally from service to service because it's a little bit more loosely coupled. It's a little bit more flexible. So that's kind of the strategy we're taking, but now comes how do you piece this together? How do we actually attack this? Which is where some of the tooling that I'm going to talk about here comes into play. API design first is the strategy we're taking to break these down, to break the monolithic down into microservices and move forward with this pattern. There's basically two different types you'll see here. I know some people have already talked about it. We heard a little bit about it yesterday. You're either looking at API design first or code first when you're doing your gen. I generally prefer API design first. That's what I push my teams for. I think you get a little bit better design up front, you think through the problem a little bit better, and you cut down on refactors and giving someone code that they then come back and say, well, it doesn't have this, it doesn't have that, and now you're refactoring off the bat. Not to say that code first doesn't have its upsides and approaches. If your team is isolated and you're building services that don't expand outside of your team, and you prefer code first, that might be a good approach. I've generally recommended, if that's the case, code first is fine, but if you're producing services for other teams, other consumers that are outside of your control, you're generally going to be better off with API design first. Kind of talked a little bit about this, but these are some of the reasons that we do that and prefer that. One, you do seem to get a better understanding of the problem. You think it a little bit through more than just writing straight to the code, kind of like TDD and patterns like that to give you the same benefit. And you save a lot of time, the refactors, the errors. Collaboration is a big deal. We have 90 plus products and many different teams across the country and other countries. And it is hard when you don't give them something for weeks or months and then you wait for the feedback and you go forward and refactor. So collaboration and doing collaboration effectively was a huge deal for us. Parallel development is another big deal. And this is actually where Swaggerhub has come into play for us to allow certain things like this to happen. I actually have one mini story about parallel development that actually worked kind of the way that I envisioned it to work. We were building an API for another team, complete other team, to communicate, to process payments. And we built it, we designed, well, I shouldn't say we built it. We designed it in Swaggerhub, produced the OAI doc, gave it to them, set up the mock. They built their entire integration before we were done doing the code at all. And their product person talked to me later in a meeting, and he said, yeah, we're done. You guys built the API. Everything's good. I'm like, no, we just designed it. We haven't actually written a line of code yet, which was an exact use case that I wanted to see, because sometimes we waste so many weeks and months on people waiting for something that we could give them in a matter of days and collaborate and be done in weeks. And so while the developers understand that difference, it was nice to hear him say that, and we actually made a lot of ground on doing that. So that's another thing that we've been focusing on, is how do we move quicker with so many teams collaborating, and the faster feedback loop that you get when you do that collaboration versus giving somebody 2 months down the road. It's already built, it's already running, and now they're asking for changes or it doesn't fit what they needed. So Swaggerhub is the tool that we chose to hit all those goals. It makes it really easy to design the documents. It makes it easy to collaborate on the documents. And I have a little demo here. I'll show you guys kind of how we use it. We're actually a customer of the on-prem version. So we have a private instance of this. It's not public. Everything's internal to our network. So I'm not going to show you that one, but I have a public one that just kind of take you guys through how we use it and how you might use it and how it's beneficial to us. So if you're not familiar with Swaggerhub, it generally, when you pop in, it looks like this. You can share all your APIs. They're all listed out. I'll talk a little bit about how we set up organizations and how we manage that inside, given that we have so many teams. But basically, I'm just going to go through here and show you guys just a quick demo of how we can use this. So if we create a new API here, and I'm going to use 2.0 because that's the APIs we already have built. We are migrating to 3.0, but due to some lack of tooling and old stuff we've already built, everything is not converted. Let's call this pricing. And I'm going to leave the auto mock on because I'm going to show you guys a little bit about that in a second, how we can use that and how it fits into some other tooling. So we'll create the API. Okay. For time's sake, I'm not going to write this thing out manually, but I will copy something we already have. Okay. And so obviously the big benefit here is now when you're sharing via Swaggerhub, you not only have this document, but you have a visual of what this API looks like. You can actually go through it. It's really easy for product people, anyone who's not as much technical, or even developers on a quick look, to kind of scroll through here and see all the methods that you have. You can go through all the parameters. If it's done well, you'll have descriptions on everything, whether it's required. They should know everything they need to know on how to call the API, as well as samples. What does it look like when you get back a 200 response? What does it look like when you get back a 400? These things are really critical if you want to do parallel development and you want someone to be able to build off this before you actually do the implementation. They kind of need to have a full picture of what your API looks like. The other benefit here, when we start getting into the collaboration, is now when you're sharing this with multiple teams, instead of passing around Word documents or going back and forth in emails or Slack conversations, it's really hard to follow where all those docs are. You can centralize your collaboration a little bit here and use some of the tools that they provide. So if someone's going through the document, another team not even related to yours, and they come down through here and they might see, oh, I expected this field to not be required, or to be required, right? They can simply not go through the back and forth of emails and private conversations that don't reach everybody else involved in the project, but they can use the tooling that this product offers. So comments are a big way to do that. You can see there's a little plus by every single line that you have. You can go ahead and click that, and you can add comment like, whatever it is, required. And I can't type, but there you go. And it stores a comment in here. And then anyone can come in here and they can see that there's comments right up here. They can review those comments. They can see exactly what line they're on. And you can reply. And you can have a little bit of a conversation about that, what you're trying to accomplish. And it's recorded. It's recorded for everyone to see. It's not private. It's out there in the open. You can collaborate on this document. You also wait to mark it resolved. So if you want to do it kind of like GitHub or tracking issues, you can go ahead and close that out. The other nice thing is when you start talking about finding bigger issues, bigger than maybe something field not being required or whatnot, you want to actually modify this. It's a lot easier to modify this and move forward than it is to rewrite the code and move forward. So for instance, if I want to say, we have a get call here on units, but it's missing a post. So they need to be able to create units. If I go back and recode that, it's going to take days. Who knows how long it's going to take. But we can simply move forward with that using these tools quite quickly. If I just go snip post model, and just to make this easier to read. It does have collapsing fields, so you can make it a little bit easier to navigate. But I can come in here. Actually, that's not what I wanted to do. And if I did that right, yeah. And so just by doing a quick modification of the document, you now have a post method. And if all this is mocked and using auto virtualization for these mocks, the teams can actually move forward and start coding against these new methods, these new changes right away. And you didn't have to spend time doing coding, developing, and getting it out there. It's a really quick way to make sure you're getting these APIs right and designed correctly up front. The next piece here is actually that auto mock. So this looks like it's turning auto mocks on by default now. So when you create an API, it automatically turns that on. If not, you can go ahead and turn it on. But the benefit of that is now, if someone wants to actually call this and see, what it looks like, they can simply take the URL here. A property ID, so we can do anything we want. Units, if it's set up right, of course. Sorry, let me see if I can fix that real quick. That's why. Hold on a second. Sorry. It had a leftover URL from our private instance, so it was calling the wrong thing. And there you go. And then you can see we haven't written any code at all, but they can call it like it was a real service. You get your response back, your headers, your complete JSON block, and they can code against this and move forward. Now this is just the static. I mean, you can go ahead and update the documents and put whatever examples you want in here. You can also use services like, I think it's Service V, that lets you do a little bit more dynamic creation of this. But that's kind of what we were using in some of our examples to let people move forward and develop before we've actually built out the full integration. The next thing, and this is important if you're using tools like this and you have big companies with many teams, is how you organize this whole structure. So you can see they belong to an organization. So this is a public org that we have out there. This is the API that I just added. And so anyone that's part of that organization can see and view these APIs, and then you can add editors, collaborators, all kinds of stuff like that. The biggest challenge that we had is, like I said, we have like 90 plus products and a ton of teams. And it's a lot of noise in here if everyone is sitting in one organization. And what I was seeing is people were going in and building new APIs from scratch, designing them. They were half built, half done, and it's a lot of noise. You go in there and you look like, well, what is this, right? It's not real, it's kind of messy. And so what we did is went with an approach. If you're designing something that you're not sure is ever going to become real and you're not collaborating, you can keep it private, right? And so here's the ownership of the org, but when you create these, you can actually specify who the owner is, right? So you'll see your list of organizations or your actual user if you want to keep it private. The next thing we did is, because we have so many teams, and many of those teams are building APIs that pertain only to their teams and not the rest of the company, they create their own organizations. So we have a central organization that's for our entire company. Anything that you might want to collaborate on with anybody else or that pertains to everyone else would go there. And anything that you have privately that works for your team and your team only, you might keep in a private organization and you could invite someone else to it. The other thing we do, because we do have so many teams that have many APIs public under a shared org, is we use the concept of projects. And so you can see I kind of just to demo it out, created a couple of teams in here, A, B, and C. It just lets you divide that up a little bit. See if you have completely separate teams, instead of having one giant list, they can all share them, but you could then specify what project they belong to for a little bit better organization. And it's real easy to add new projects. You simply come in here, new project, team D. Oops, well, if you don't hit it too fast like that. You can assign APIs to it that already exist, invite anyone that you want to it, and now you should have a new team under there. And so you probably, if you're going to use tools like this, you do want to spend some time figuring out how you're going to organize it, or it becomes like a bunch of other tools that become messy and cluttered, and people stop using them if it's not simple. So it's really important to get that set up. That's kind of how we go through and how we use this tool. There's also a lot of other things in here. You can auto-generate code, SDKs, things like that, especially if you have teams using multiple stacks, different languages. It's usually a good head start to get them going really quickly. So there's a lot of benefits to using tools like this. Let me pop back here. Okay. And so the next thing we touched on a little bit is connecting all these things. So now we started to have a bunch of different services deployed with a bunch of different URLs you now have to configure and piece all together. How do you do that? How do we manage that? We didn't want to have people configuring that in config files all over the place, having to change it every time a URL changed or a container went up or whatever the case may be. So a couple of ways you can do that. We talked about it a little bit. You can go point to point on everything. I would recommend that the more services you put up, you probably don't want to do that. It's going to become pretty messy if you have hundreds and hundreds of services all configured point to point, and you don't really have any good orchestration over that. A couple of things you can do, we talked about a little bit earlier, is a service mesh. Some examples of that are Istio, Linkered. Kong is moving toward that. And you can use API Gateway patterns, which is similar to a service mesh, but I would say a more centralized pattern, more focused on layer 7, HTTP and things like that you want to do. Whereas a service mesh is probably more your services talking to each other. It's in the network. It's a little bit more at layer 4. You're probably not doing some of those advanced pieces on that. So what we do right now is we use an API gateway for both internal and external. The plan is to move later internally to a service mesh. But right now, for simplicity, we start with the gateway pattern, which gives us a lot of flexibility. The product that we use for that is Kong. Is anyone familiar with Kong, just out of curiosity in the room? A couple of people. So Kong is an open source API gateway. It's been around for a few years. It's all API driven. And like I said, it's open source. It's completely free, at least to start. They do have enterprise versions, and we are an enterprise client. And I'm going to show you guys a demo here in a few minutes. And I will show you the enterprise version just because it's a little bit easier to go through a GUI in a presentation like this than it is to sit and look at command line stuff and API calls. But you can use this right now. You don't have to pay for anything. You can go download it. You can configure it. It runs anywhere on any machine. It's really easy to use. The other good thing about it that we're hoping to use going forward is, right now it's more focused on an API gateway, but in recent developments, they are offering service mesh deployments as well. And so for us, the upside is we're hoping that as that migrates, we can use that to move to a service mesh pattern as well. And now we're using one technology and not 2 or 3. It's just a little bit easier to manage. And let me show you guys a quick demo of how you might use that. Sure this is running. Okay, so this is the enterprise UI. Like I said, this is not part of the open source free version, but a little bit easier to manage quickly and to show in a demo like this. So basically, when you're configuring stuff in a gateway, everything's going to share the same host URL, but you're going to be able to set up your path to route wherever you want, basically. And using a tool like this, you can simply use something that we've already done with the mockup in Swaggerhub. You could come in and create a new service. Let's call it pricing. I'm not going to go through every setting for time's sake, but there's a bunch of settings in here you can do for timeouts, all that kind of stuff on how it connects. Let me go back here. So in here, when you're creating a service, you're basically telling it where the root API lives and where it's going to route to. And once you have that set up, you can now set up paths or routes, basically. This will let you set up anything you want in the API. So if you build an API that has 25 endpoints, whatever it is, you don't actually have to expose all those to other teams. So if you have certain things that you want to keep private or that you don't want to allow post access on, whatever it is, you want get only, you can control all that. Most gateways all have this functionality. But basically, we pointed what I set up in Swaggerhub as the base level. And now if I wanted to create a new route and say, to get that pricing, supports get only. If you wanted to support other models, you could put post, put patch in there. And you can define the path. So I could just call this simply pricing, which didn't exist in the actual service that we mocked up. And so it's kind of like a URL rewrite, if you will, a little bit. And so you can create that, and now you could have someone call the same service, but not directly, so you're a little bit decoupled from what you've built, but through a gateway. So they can call. And normally, obviously, you wouldn't use localhost. You'll have a much nicer, prettier URL, but for sake of this, it should work. And now it's just pricing. That was the match we set up, and then you follow the rest of the service. So it was property ID and units, and you can see it returned the same one. This is actually the one we virtualized in Swaggerhub. And so you could make that route whatever you want. It doesn't have to be whatever you created. If you're creating things in containers and you're spinning up many containers, you may have a lot of different routes and URLs that have long, ambiguous names or container IDs. It's really easy to set that all up. Another thing, just to show you guys real quick, that you can set up in here when you move forward with gateways, if you didn't want to provide access to just anybody for this and you wanted to start tracking it and have different things like that, you can actually set that up pretty easily with tools like Kong and any other API gateway. So if I wanted to say, okay, this requires an API key. You can't use this without an API key. You could simply create a plugin, or not create a plugin, but generate one. And now we have basically said that this API will require an API key and a header called API key. And that will apply to anything that hits against that service we built. So now if we go back and we try and run the same call, we're going to get a 404. It's or not a 404, sorry, a 401, unauthorized. Going a little farther, if you want to grant access to that, you can simply come in, create a consumer. Issue that consumer an API key credential. And now, if I go back there and make the same call, but I pass it the API key header, well, if I spell it right. We're back to where we were to get a valid response. That's just a real quick high level of the things you can do with an API gateway. Obviously, it goes much more in depth. We could have entire sessions on how to use API gateways and the benefits. But I just want to give you guys just a quick idea of how you can use those types of things. You could even use them with virtualized services if it was of an advantage to you. And so that's kind of a quick, high level. I know it's a wide range topic to go through in 30 minutes. So it's really condensed, trying to get through, just trying to give you an idea of how we approach things and ways you can do this and what kind of tools you can use. That's kind of what I have. And I started at the beginning. But is there any questions? I guess we can move to questions now.
Any questions in the back? Just being conscious of time, we'll just take a couple and then let everyone kind of go on to sessions. Sorry.
When you use the Kong API Gateway to modify the user access path, then what do you rely on for accurate documentation?
For documentation?
Yeah.
For those changes?
Yeah.
So what we do, so Kong itself, this is where you get into dev portals, and I didn't really get into that. I know some people have talked about it yesterday. Kong itself has a dev portal, We haven't employed that yet. We've actually used internally Swaggerhub to kind of communicate some of those changes. So what I've traditionally done is we would go back into Swaggerhub and I would update that to show that, okay, it requires a header called API key and puts in the information there. A more advanced phase we're looking to do internally is move to a portal, which is just accessible by anybody in the company. So you go there, you navigate your domains, you find all that docs. Externally, we do have a portal, and so any kind of authentication information, authorization would be there. But we would document it that way for now to get that out.
Thanks.
Thank you. Terrific. Well, thank you, Travis.
Did you have a
Sorry.
question?
Do you have a question?
Is the portal your marketplace where you make APIs available?
Yeah, well, there's two pieces. So yes, so we, as a company, the team that I run has a platform, a public platform, and so we have a portal. And that dev portal's out there on the internet that you can find whatever APIs we sell and packages are there. It has all the documentation on that portal. Internally, we don't have that yet. We're working on it. One of our bigger problems internally was that very same thing. Like internally, we don't communicate well to other teams what APIs are available. How do they even find that they're available? And even when people have documentation, even if they're using, they might be using Swagger UI and things like that, it's sitting on different URLs for everybody's individual service. So internally, we've kind of used Swaggerhub as the portal for now, but we're going to be moving, having another portal in the future, although I hear Swaggerhub is creating a portal next year, so we might use that. We'll see how it goes. But yeah.
Okay, but Kong does have ability to provide a...
Kong in the enterprise version. So
Okay.
Kong open source version is just the gateway. It has a full API, but what I showed you guys in the UI, that's not part of the open source package. But as part of the enterprise package, you get the administration UI, which is what we looked at, and there is a dev portal. So and a fully configurable dev portal that you can control. So
Okay.
that's there if you want it.
Can I ask one more question? Sure, there's one more. So when you were talking about design patterns, the API communication patterns, would you make a different decision if you have to entertain multi-tenancy versus like no multi-tenant application?
As far as whether you're doing through a gateway or doing async communication?
Yeah.
I mean, I think it depends on your use cases. Some things are more set up for async communication, and it really depends on what you're doing. So we have a wide mix, like I showed. In some cases, we're actually not very sophisticated in async right now. We're moving forward with things like Kafka and RabbitMQ to do that. And in some cases, it's cleaner. People want a request response, like right now kind of thing, and that's when we use the gateway pattern. So it really depends on your situations. Regardless of multi-tenancy or not, I think you could use both use cases. So it's something you kind of have to evaluate. I think in our case, we're looking to offer both in most cases. So async when you want it and request response when you want it. It really depends on what exactly you're building and how it works and what the dependencies are.
Thank you. Perfect. Thank you, Travis. That was really,
All right.
really
Thank you.
cool.